Okay, for the next talk, please welcome Federico, who's going to tell us about, which one is this? repcloud.
repcloud.
It's a repacker for Postgres. Thank you very much.
Hello, everybody. Can you hear me? All nice? Okay. Thank you. My name is Federico. I'm Italian. I lived in the UK for a while and now back to Italy. So very happy to be here. I will present this tool I've written over probably 6 weeks. And but before things, let's start with me. This is my cat. He's much better, cutier. I'm ugly, so it's much better to show him. My Twitter is @4DrScarf. I'm a huge fan of Doctor Who. And I was born in 1972. I look younger, but I'm a Time Lord, right? So passionate about IT since 1982. Joined the Oracle Secret Society in 2004. Fell in love with Postgres in 2006. And I have a Postgres tattoo on my left shoulder, along with this guy is just joined recently. So I'm very committed to the project. I'm also involved into the Postgres community. Before starting, little disclaimer, I'm not a developer, not really Pythonic. I'm a DBA, so I'm hated by everybody, which is the role of the DBA, and I hate everybody. So to put things in the right perspective, I use tabs. So please let the hate flow through you. So let's start with the stuff, with the strong stuff. How many Postgres users in the room? Whoa, I love you. I love you all, despite I am a DBA. PostgreSQL is the most advanced open source database. It's a great product, gaining momentum. I'm very impressed by that, and I'm very happy with that. Available as a database as service on cloud providers. So we have RDS, Heroku, other stuff, which limit the action you can do on PostgreSQL. And unfortunately, have his own drawback too. It's not good as in some areas. He needs improvement, or it's just architectural stuff. So we need to live with that. So what the point I want to stress today is the MVCC. How many of you knows what is the MVCC? Thank you. So multi-version concurrency control is the way Postgres makes things consistent in read and out. It can manage stuff in read and write with very, very minimal lock. The implementation is very efficient. It's very different from other databases. Postgres, it doesn't have the rollback segment, for example. And the snapshots are managed on the data page. It's amazing. You get everything you need for reading consistently directly on the data page. The data page is the problem at the same time, because the transaction ID is stored inside the row in 2 system fields. A transaction ID is just a 4 bytes integer. So it starts from 1, wraps, reaches 4 billions, then it wraps again. There's a mechanism to avoid the wraparound failure. Is a topic for a different talk. But 2 system fields are used for track the visibility of the row or tuple, as it's called in Postgres. There's one field is the xmin is called also the insert transaction ID. When the tuple is created, the transaction ID which created the tuple is stored inside this field. And then there's another one, xmax, which is set when the tuple is deleted. So Postgres, it doesn't remove immediately the rows from the physical layer. It leaves in place. And this information is used for tracking the row visibility. But there's no field for tracking the updates. This is quite a mystery. Nobody knows about this thing. But in Postgres, there's no such thing like an update. An update is made using an insert delete inside the same transaction. The old row version is deleted, the new row version is inserted. So you get 2 rows, one becomes dead, and so becomes wasted space. But it's still needed for running transaction that needs to see these rows. But these old row versions are removed by vacuum, when vacuum kicks in manually or automatically, And when the rows are updated, they might change the data page. It's not automatic that the row stays inside the same data page. The data page is the data block, the physical block. And when this happens, when the row changes the data page, the indices need to be updated as well. And this may result in bloat. The indices bloat massively just because the tables are updated too much. So how to reduce the risk of bloat? Database design. Data model should avoid tables with large rows. They should be splitted. The third normal form is very helpful in that thing. Most of the grouping the most updated fields in separate tables is a massive strategy to avoid bloat. Because if you have one row of 200 bytes and you update just a Boolean flag, you generate another 200 bytes. Whether you change the Boolean or change a different field, those fields should be used for looking up to the rest of the data. Remove the unused indices. There's a way to query Postgres for knowing that thing. Or doing routine maintenance, vacuum, very low impact, less effective on indices, or reindex. High impact, high effective, you can reindex stuff, but until Postgres 11 is a blocking procedure. So locks your table in read-only mode, and sometimes can prevent also the reads. It depends how the index is used. Dealing with an existing bloat, I found databases in very, very bad conditions. Indices, hundreds of gigabytes for storing just 2-3 gigabytes of data. So how do you deal? The first thing built in Postgres is vacuum full, but this is a massively blocking procedure. You get the table locked in exclusive mode until the vacuum is complete. And on a cloud-hosted database with hundreds of gigabytes of table, it can take days because the IOPS are limited. It's not really feasible, this thing. PG repack is historically the way for repacking tables without locking is a very good tool, but the problem is you need to install the extension, and on cloud database you can do that. So in June, I had this customer, so they had exactly this problem. Cloud database with the impossibility to install PG repack. So I came out with this crazy idea, and believe me, it was incredibly crazy, considering all I had to develop. So they said, oh, let's go for it. And that is the repcloud, repacking in cloud. This is the reason of the name. It uses a similar strategy like PG repack. PG repack creates a new table, regenerates the data, replays the data against this table, and then swaps physically the data at system catalog level. repcloud, it doesn't use this strategy, so it's a logical procedure. It requires minimal access on the database, and for example, on Heroku, RDS, I think RDS recently added PG repack to the list of extensions, so probably it will be a better idea to use PG repack if available. But on all the others that do not allow this sort of extensions, repcloud can help to reduce the bloat of the tables. So how this thing works? Create a new table like the original one, empty. Creates a log table with the same data type of the original table. Postgres have this fantastic thing called composite data types, which describes also the tables. And then the trigger stores the log changes that are happening onto the original table into this log table. Then the data is copied with just a select insert into the new table. The log changes are replayed against the new table, and then attempts to swap the table. So renames the old one, renames the new one to the old one, and live long and prosper. Not exactly, because the swap is absolutely not trivial, because the Postgres dependency system. It's something you will see if you try to drop a table when there is a view attached to the table and you get, oh, I cannot drop it, you have to use Cascade. Don't use Cascade, it's very dangerous. So even when you rename your table, all the dependent objects follow that table. So you have to rebuild exactly the same objects onto the new table, and then you can drop safely the old table. Otherwise, you will lose information. So what has to be recreated? Sequences, of course, otherwise any insert with the default value using that sequence, it will fail. Views, materialized views, and foreign keys, but the problem is any other object that is related with these objects needs to be rebuilt as well. So the entire chain of dependencies has to be rebuilt backward, and then everything has to be dropped and recreated in the correct order, otherwise it will fail. And also, we have another problem, the deadlock. The deadlock is when one transaction is waiting for the lock on another transaction, which is waiting for the lock on the previous transaction. There's no way to exit this chain. So Postgres kills one transaction randomly and frees the deadlock when it happens. And this happens in particular when you have a chain of foreign keys. So this table is referring to this one is going back, this one is going back there. So if you try to rebuild or drop these foreign keys, meanwhile they are in use, so they are being checked and validated against the data changes, you will get a deadlock. There's no possibility. This is a schema, very simple. This is the PG bench schema with foreign keys. It's very useful for testing this sort of things. And the first thing I learned when I tried to run the swap, it was, oh, deadlock. So how did I approach this thing? I decided to add the choice on this tool, so the user can decide which strategy to use. Basically, repcloud does nothing when he detects the deadlock, so he waits for the database, but it's possible to tell repcloud to kill or cancel the offending query, the other query. So the system automatically checks if there is a deadlock, potential deadlock happening, and one of the blocked queries, not the one that is running the swap, is cancelled or killed. But sometimes it's not a good strategy for this thing. So it's also possible to run just a prepare swap. So everything is made until the end before the swap. So the table is created, the logs are populated by the trigger, there is the replay functions running to replay and catch up with the existing table, so it's possible to stop the application and say, okay, now we can swap without the risk of deadlock. So few seconds of downtime for swapping the relations, I think is something it can be afforded, rather a long-running vacuum full. Also, it can change the fill factor for the table. Fill factor is a very useful thing. So you can set the parameters. This is something still I'm working on it. At the moment, it can set the fill factor. But my idea, it will add the change table space, change index table space. Everything is configurable at this level. So it's possible to create the new table with a different fill factor. So the new table will be less impacted by bloating because there will be more space inside the data pages for the updates. This is one of the strategies for designing tables that might be affected by the bloat. It can clean up the JSON-B and JSON fields from the null keys, so it makes the JSON fields more compact. And also, it's possible to remove the keys, but just from the JSON fields, JSON-B fields, because the function that runs this operation is present only for that data type. More will come. And this is the tool in short. I would like to recognize, give some recognition. This is the company that gave me believed in me and gave me the permission to release this thing as an open source project. It wasn't supposed to be that, but I think it might help a lot of people. The dependency resolution is derived from the PG admin team. I used their queries adapted to my need. They were amazing. They saved a lot of time for building up the dependency system in Postgres is insane. So you have to get through a lot of outer join for getting everything. And also the replace strategy is inspired by the PG repack code. So waiting for the transactions before starting effectively the copy is something inside the serialize, the transaction isolation level is something that helped me a lot to understand how to approach this problem. This is the GitHub project. This is my GitHub. There's also other projects. The other important project on this GitHub page is PG Chameleon, a replication tool from MySQL to Postgres. PG Chameleon is very usable and is something I want to pick up. I've been distracted in the last year, but it is something I want to improve. And also this thing is available on PyPy, so you can just, it's an alpha release at the moment, but we tested on production. It worked incredibly well. For repacking a 300 gigabyte table, it took about 4 days, which were supposed to be downtime, and it wasn't, so the customer was very, very happy about that. And the license terms are the Postgres license. I like this license. I think PG Chameleon started as a BSD license. It will move on the Postgres. It makes more sense. It's a Postgres-related project. And if you want to break it and report, or you want to help me to build up this thing, I think I will write the collaboration guidelines very, very soon for this project. I will be very, very happy to get any help about that thing. Those are my contacts. This is my blog, pgdba.org, where I write stuff about Postgres, Twitter already said, GitHub, and my LinkedIn page. Work under the Creative Commons. And if you want to hear about horror stories tomorrow, I will speak at the Postgres Dev Room about RTFM. Anybody knows what RTFM means? Sure you do. So I will tell about interesting and funny things. It's the last talk of the day, so I have to be entertaining. And that's all, folks. And there are any questions? Thank you for listening.
Not directly related to the repcloud, but do you consider partitioning as the solution against bloat?
Well, partition is not designed for a solution for the bloat. It's for having a more efficient storage when you have a monolithic table. So solution for the bloat is looking at the storage parameters. So fill factor, trying to avoid unnecessary updates. And one thing you have to look into the pgstat all tables. There is the field called toop-auth counter or something like that. I don't remember. My shared buffer is limited. But there's something with the hot inside. If this counter increases, it means the tuple, when it's updated, it stays inside the same page. So it's a very good thing. So if you have a lot of updates and a similar numbers on the other field, you are doing very, very right. Any other questions? Cool. That's all right.
Thank you, Federico.
Thank you.